Hello again, and this is the logarithm review. I have got things kind of squished in on the first screen, but I did that for a reason. Logarithms are the same thing as glorified exponents. Now, you don't have to know your exponential laws, but you know the exponential laws, you should know the first three or four. And the first three or four state that if you have the same base, and that's important, the same base, then, and you're multiplying, then you use the product rule. Product rule says that if you're multiplying, you add the exponents. If the bases are the same and you're dividing, that's called the quotient rule, meaning that you subtract the exponents. And there is a power rule, but it's a little bit different with the logarithms, and I don't want to go into that. But the first two rules of your exponential laws are kind of like your first two rules for your same base. Here's the product rule right here. If I have the same base and I'm multiplying, I write that out as a addition problem. If I'm dividing, then I write that out as a quotient or a subtraction problem. Here is the power rule. Power rule states that if I have a log raised to a power, I can bring that power out front. Now, I'm going to erase what I just did, the highlighted parts, so you can write down all of these. You should already have these exponentials down from an earlier video in this review. Now, why did I put the graph up there? I put the graph up there to show you what type of graph we're talking about with an exponential versus a logarithm. And as you can see, they are symmetrical around the oblique asymptote or the 45-degree angle. So I wanted you to see the relationship because exponentials and logarithms do have a relationship with each other. And I'm going to kind of take off the highlights, and I want you to take a minute or two, and I want you to pause the video, and I want you to write these and add this graph to your parent graphs, and that'll probably be the last one that you have to add. Because I'm just about finished with the algebra review. But I think you will find it, I think you'll find it beneficial to have the y is equal to 2 to the x and the y is equal to log base 2 to the x to have it on your parent graphs. And I think it, like I say, will be the last graph that you have on there. I would include an index card with your exponential laws, which you should already have from a previous video. And then make sure you have the properties of logarithms over here, and I'm going to go over those again in just a second because this video is on logarithms. So pause the video and make you out 2 index cards and add that graph to your parent graphs. And I will be back in just a minute with some problems. So here we are with some problems, and I'm going to just do a few rewrites. First of all, I want to go over here, and I want you to make a note of the following problem. I want you to write this down. This is very important. This is called the definition of a logarithm. You're going to use this a good bit. This is very important. So you need to write this down. These are some properties right here that you need to put to memory or, put on your index card and make sure you highlight them as properties. Like, always remember that if the 2 bases line up, that's equal to 1. If the log of 1 is always going to be 0. Those are 2 that you should remember. Okay? You can't take the log of negative or 0. You can't take the log, so you need to write that down. And anytime the bases are the same, you can rewrite as x. If the bases are the same, you can rewrite as that exponent. Those are basic properties, okay? This one is what we call the quotient rule. I mean the product rule. Very important. This one is called the power rule. Very important. And this one is called the quotient rule, which is very important. And there's a change-based formula, which is log base b of, we'll just say log base b of x is equal to log of x, log base 10 of x over the log base 10 of b. And let me go ahead and stress one more thing before we get started. The log base 10 is equal to log on your calculator. And I'm going to put that in kind of a button form so you'll know. And log base e on your calculator is the natural log. So you need to make sure you know that. And this is called the change-based formula. It's easy. It's not really, I really stress the ones that I've circled up here. This one, this one, this one, the four important ones I put stars beside. The four, definition of a logarithm, the product rule, the power rule, and the quotient rule, those are very important. For instance, one like number 7, 2 to the 4th is equal to 16. This is definition of a logarithm. Definition of a logarithm writes an exponent as a logarithm or a logarithm as an exponent. So if I want to rewrite that, I just bring my log base, and they say different, base A, base B. I will use base A of x equal to n, and that's usually y, gives us, either way, a to the y is equal to x. That's the way I write it, okay? So I'm going to take my first one. 2 to the 4th is equal to 16. 2 to the 4th is equal to 16. And now I have x, I have y, and I have a. So now I'm going to plug log base 2 of 16 is equal to 4. So I just wrote this exponent as a logarithm. So we'll do one more. Let's do number 8. Number 8, first of all, radicals and calculus don't mix. So I'm going to change that radical to a rational exponent equals 8. And now that's a to the y is equal to 8 log base 64 of 1/2, of 8 is equal to 16. Is equal to 8. Sorry about that, I went to the other problem. Log base A, see what happens when you don't write everything down? Let me just start all over on that one. Okay. A to the y is equal to x. That's where I messed up, right there. Okay, so there. So log base 64 of x is 8, is equal to 1/2. So that's how you use the definition of a logarithm. And you can go both ways. You can go from a logarithm to an exponent, or you can go from an exponent to a logarithm. All right, let's try. I'm not going to do the evaluate without a calculator, or you can with a calculator. Basically, you put that in change base formula, and I think that's how you do that. I'm going to the, down here at 16, I'm going to do those because that's using the quadratic, the quotient rule and the product rule. And we're going to play that game. One of these days I'm going to get training on this board. All right. So, look at number 16. 16 says log of 10x. Log of 10 times x. So that's multiplication. I'm going to use the product rule. So that's going to be log of 10 plus the log of x. I just rewrote that as a product. Okay? So let's do number 22. That's the quotient rule. So that's going to be log of the square root of 3x over 7. And that's going to be equal to the log of the square root of 3x minus the log of 7. Now I'm not finished there because that 3 and that x is multiplied together. So that's going to be log of the square root of 3 plus the log square root of x minus log of 7. And you can rewrite that as log of 3 to the 1/2 plus log of x to the 1/2 minus log of 7. And using the power rule, 1/2 log of 3 plus 1/2 log of x minus log of 7. And that is how you use the quotient rule, the product rule, and the power rule together. Now again, I'm not supposed to be teaching you how to do this. When I showed you these properties, you should have said to yourself, "Oh yeah, I remember those. We went over those. Yeah, I remember you write them as a product." You may not remember how to do all of it, but it should be in there. If you've never had this before, then you probably don't know what I'm talking about. Again, that's not the reason for the review, is for just that reason, to review. If you've never seen this before, then chances are you need to take the class of, that's teaching this, whatever class it is. So let's do another one. We just did 22. Let's do 27. Let's do 17 right here. Natural log of xy over z. Now the same rules apply with the natural log as the log, because the ln is the log base e. So it doesn't matter. So that's going to be the natural log of xy minus natural log of z. And then that's going to be the natural log of x plus the natural log of y minus the natural log of z. Now we can also go the other direction. Look at 23. Well, let's do 21 first. I like 21 because it's got a lot of stuff in it, and that's what a lot of standardized tests use. 21 and 22 are real good test questions. So natural log of x to the 5th, y to the, I'm sorry, not y, z. Z to the 2nd over y to the 3rd. And I'm going to rewrite that as the natural log of x to the 5th plus natural log of z to the 2nd using the product rule minus natural log of y to the 3rd. Now we're not finished because you can use the power rule and you can bring that 5, that 2, and that 3 out, and you get 5 natural log of x plus 2 natural log of z minus 3 natural log of y. And of course, we can rewrite going in the other direction. And when we rewrite going in the other direction, all you have to do is think in reverse. So here is log 23 says the log of 7 minus the log of x. Well, that's minus, so that means I'm going to be using division. Log of 7 divided by x. Log of 7 divided by x. So let's do number 26. (26) says log base 2 of 5 plus log base 2 of x minus log base 2 of 3. Now, I'd like to remind you, you can't do these problems if the bases are not the same. In this case, the bases are the same, but I just want to bring that up. Every once in a while, a test question will be log base 2 of 5 plus log base 3 of x. You can't do anything with it. So make sure always the bases are the same. And we're going to use our product rule and our quotient rule. So that's going to give us log base 2 of 5 times x over 3. 5x over 3. And that was number 26. Number 28. Oops, sorry. Number 28. Number 28 says 2 log of 8, 2 natural log of 8, plus 5 natural log of x. Natural log of x. Power rule goes up first. So that would be natural log of 8 to the second plus the natural log of x to the fifth using the product rule. Natural log of 8 to the second x to the fifth, which is equal to the natural log of 64x to the fifth. Now, as I did those problems, you should be saying to yourself, oh yeah, I remember doing this, or I've never seen this before. Chances are, if you've never seen this before, then, some Algebra 2s include it, some do not. But the reason you're taking this review, Algebra 2 review, is probably for a placement test. So if you don't know how to do it, it's not a big deal. The main thing is that you remember the algebra for the algebra portion of the test. But I throw this in here just as an extra, kind of like the trig and the probability and statistics. I add that in there just for an extra little bonus, just to, bring the memories back so when you do see it on a placement test, you are able to do it. Now I'm going to bring these 3 back up again while I switch over to another section. There we go. I want you to make sure you have these down on index cards as well as your paragraph. So pause the video, and here in just a second we'll be solving some logarithmic equations. Now I'm going to talk about solving equations with logarithms. In other words, solving logarithmic equations. And there's several ways you can solve logarithmic equations. Solve log equations. One way is by using the definition of a logarithm, which is log base A of x is equal to y. And that gives us a to the y is equal to x. Okay, that's one way to solve an equation. The other way is to look for the same bases. Because if you look for the same base, and you do have the same base, the log base A of x equal to log base A of y, if these are the same, then you set x equal to y. So if you have log base A of a polynomial equals log base A of another polynomial, then you can set those polynomials equal to each other. And third, take the log of both sides. Log base 10 or log base A, I don't really care. And that is basically how you solve logarithmic equations. Now, the trick is knowing which one to do when. Okay? So, with that being said, let's go ahead and look at a few. I'm not going to do all of them, but you can write them down, and there we go. Here we have the same bases. So you can set, I'll do two of these. I'll do the first one. The first one says log base 10 of 5x is equal to log base 10 of 2x plus 9. Now, since these are the same bases, you can set these two equal to each other. Take the little bucket across the river. 3x is equal to 9. X is equal to 3. So that's a case of all of these are the same basis, all of them. So I'll do number 2, and you can do number 3 and number 4. Number 2 says log, and if there's nothing there, it's assumed to be a 10. Kind of like when there's nothing on a radical, it's assumed to be a 2. Log base 10 of 10 minus 3x. And that's going to cancel. 10 minus 4x is equal to 10 minus 3x. The 10's cancel, and you're left with negative 4x is equal to negative 3x, which is not true. This is a contradiction. So therefore, the answer is no solution. No solution. Because negative 4x cannot equal negative 3x. Or if you divide by 4, you're going to get x is equal, or divide by x on both sides, you're going to get negative 4 over x is equal to negative 3 over x, and that's not right. Okay? So you can try number 3 and number 4. So stop the video and work number 3 and number 4, and you should get 4p minus 2 is equal to negative 5p plus 5, and 4k minus 5 is equal to 2k minus 1. Because these are examples of logarithms with the same base. Next page. Oops, sorry. Here is the definition of a logarithm. Now, how do you know that? Because you don't have log on both sides, for one thing. So, when you don't have log on both sides, first thing I would do here is subtract 2. And you get log of negative m is equal, 4 minus 2 is 2. There's our arbitrary mark that shows up every now and then. Now, this is the same as log base n of negative m is equal to 2. So, definition of a logarithm says log base a of x is equal to y. That yields a to the y is equal to x. So, a is equal to 10. Y is equal to 2. So 10 to the second power is equal to negative m. And 100 is equal to negative m. M is equal to negative 100. And of course, you plug that negative 100 in, it's going to be negative 100, which is equal to 100. So here, same thing, except I'm going to take that negative 6 using the power rule, and I'm going to take it up here, and that's going to give me log base 3 of x minus 3 to the 6th power is equal to negative 24. And now I'm going to write a 3 to the negative 24 is equal to x minus 3 to the 6th power. And this is going to be 1 over 3 to the 24th is equal to x minus 3 raised to the 6th power. And you can take the 6th root of both of these, and that's going to give you 24 divided by 6 is 3. So that's going to be 1 over 27 is equal to x minus 3. So I'm going to let you finish that one. Take the 6th root of both sides, and that should finish that one out. Again, I'm not teaching you how to do this. I'm teaching you, what you should remember. And again, I don't know. Some algebras go to logarithms. It depends on if you're in algebra 2 or algebra 3. And then some people don't cover. Here we have log. You got 2 logs. So the first thing I would do is rewrite these using the power rule. I'm going to go through and show you this would be log of 8x is equal to 2, definition of a logarithm. This would be log of x over 2 is equal to 1, that's definition of a logarithm. This is log of 2x is equal to 1, definition of a logarithm. Here you have the log of both sides, so the same base, log of 7x is equal to log of 37. The logs are the same bases, so you get 7x is equal to 37 and solve. Here you have log of 2 times 4x squared equals 1. Log of 8x squared is equal to 1, definition of a logarithm. And here you have the same bases all the way through, so that's log base 9 of x plus 6 over x is equal to log base 9 of 2, and the logs cancel, and you have x plus 6 over x is equal to 2, and multiply both sides by x, and you get x plus 6 is equal to 2x. Bring the x is equal to 6. I think you get x is equal to 6. So make sure you know how to rewrite. Make sure you know the definition of a logarithm. Rewrite. Make sure you can rewrite logarithms in terms of the product rule, the power rule, and the quotient rule. Make sure you know the definition of a logarithm. And make sure you know how to either take the log of both sides, or make sure you know if you have the same log base. If you have the same base, then you can set them equal to each other, just like I did here on these. And that should be your review of logarithms, whether it be rewriting or equations.